Alright, so these questions from 5.4 are based on graphing equations. Number 15, what we basically need to know is that the number of turns that something can have is essentially one less than the highest power. So if this has a power of 4, that means the maximum number of times this graph could turn would be 3 times. And here's a rough sketch of what that looked like. Every turn is basically where it hits like a maximum in. So because it's raised to the 4th power, it could have a maximum of 3 turns. So that's option D. Okay, this one right here is the location principle basically says where did you cross from a positive to a negative number? Because that's in between positive and negative. If you're on a graph, here's the positive y's, here's the negative. If you cross, well, there must be a 0 somewhere in between where you cross. So this is negative, that's positive. So that means there must be a 0 between x equals -1 and 0. And there also must be a 0. This is positive, now we're negative, so we must have crossed also between x equals 1 and x equals 2. Okay, this one right here says find the coordinates of the max and the min. In order to do that, we need to be able to see the graph. So I'm going to take this equation and put it into a graphing calculator. Go to y equals, and I plug that in, x to the 4th minus 2x cubed minus 12x squared plus 8x plus 2. So there's our graph. And then we will hit we'll hit zoom. Let's go to zoom. And then it's usually a good idea to do zoom standard to see if we get a good picture. And we don't get a great picture. We can't really see the bottom. So we could also do zoom fit, see if that gives us a better picture. If it doesn't, we can do some other stuff that's not a better picture. So let's go back to zoom standard. And let's just zoom out a little bit so we can see slightly better. We want to zoom out, so I just press enter, and that's still not great. So here's what we can do as a third option. We have this graph where you can see a max right there, and because this is x to the 4th power, we know it's going to have at most 3 turns. So there's one turn that we can see. We can't see these other 2, so here's how you can fix that. Go to window, and we want to reduce the y number. Right now y is only going down to -10. Let's go to -20 and see if that gives us a better picture. Not quite, so let's go down. Let's try like -40. Let's see if that gives us a better picture. Okay, now we can see one of them. We still need to go a little bit further to see that other one. So I'm going to the minimum y value. Let's make it -60. And now we can see them all. Okay, the question asks us to find the coordinates. So let's find them. So we go to second calc, and let's start by finding the minimum. The minimum is this one right down here. I'm going to go slightly to the left of that. I'm using the arrow keys. You can see those lighting up in red. So I'm to the left of that minimum. I press enter. Now I go to the right, press enter. And there's my first minimum. And we can just round that to -2. So it looks like x equals -2, y equals -30. So let's put that as our first coordinate, -2, -30. That's the first, and that's a minimum right there. Okay, then we also have another maximum. So we have a maximum, we have another minimum, so we need to find what those coordinates are as well, so we'll get those in the same way from the graph. Let's find this maximum up here, so we'll go to second calc. This time we want a maximum. And we go to the left of the maximum, press enter, go to the right, press enter, and that looks like 0.31 and 3.27. So 0.31, 3.27 is going to be our next one. That's a maximum. And then finally we need to find that last minimum, so let's do that as well. So we'll go to second calc, we will find a minimum this time. Going to the left of that minimum, then go to the right, press enter, and guess, and we get 3.19, -55.96. So 3.19 is right here. -55.96, and those are our relative. By the way, relative means that it's not the absolute minimum or absolute maximum. So if you remember this picture, let's just go back to it. Okay, these points right here, they're not the highest and lowest points. They're higher or lower than everything in the immediate neighborhood. But for example, these lines both go up forever, so that max is not an absolute maximum. It's just relatively higher than the other stuff around it. Alright, this is section 5.5. This is on different types of factoring, and both of these are called either the sums or the difference of cubes. So So these are the formulas for recalling those. The sum of cubes, you're summing two things raised to the third power. The pattern, the signs go same sign, so they're both plus, opposite sign, last one is always plus. What you put here and here is the things that you're cubing, so I'm cubing A and I'm cubing B. And the A's exponents count down, so A to the second, A to the first, and the last one is A to the 0. The B's count out B to the 0, B to the first, B to the second. And the difference of cubes is very similar. It's same sign, opposite sign, the last one is always plus, and the exponents work the same way. So these are our two formulas that we can use now for 18 and 19. So let's look at 18. 18 is a sum of cubes, and we always start, when it says factor completely, we always see, can we pull out a common factor? Because these numbers right here, 2 and 54, are not on this list of perfect cubes. And in order to be able to factor this, these numbers that I'm writing here are things raised to the third power. In order to be able to factor, we need to find some of these numbers appearing. If we look at it, we can pull out a 2. When we pull out a 2 from 54, we get 27x cubed. When we pull out a 2 from this, we get y cubed. 27 is a perfect cube. It's on that list, so now we can use that. Okay, what we need to ask ourselves is, what did we cube to get 27x cubed? We must have done 3x to the third power. And in here, we must have done y to the third power. So let's follow this pattern. So we have this. We have the same sign is plus, opposite, and the last one is always plus. The first thing I cubed was 3x, so that goes right here. And then it's going to be 3x to the second power, 3x to the first power, and then the last one is 3x to the 0. The second thing we cubed is y, so y goes here. It's y to the 0, y to the first, y to the second. And then all we can do from there is just clean this up slightly. So the final answer will be 2 times 3x plus y. And then this thing, 3x, the whole thing squared is 3x times 3x. That's 9x squared. Plus, sorry, it's supposed to be minus 3xy. And then plus y squared. And there is the final answer. Alright, number 19 is a difference of cubes, because there's a minus right there, so we will factor this. There's no common factor that we can pull out, so I'm not going to be able to do that. I'll just rewrite this. Okay, what did I cube to get this? Well, I must have cubed 3 to get the 27, but I couldn't have cubed x, because x to the third won't be x is 6. X squared, that whole thing cubed, would give us x is 6. And then we have the minus 1 right there. Okay, so now we can set up our pattern with the signs. It goes same sign, minus, opposite. The last one is always plus. First thing that I cubed is 3x squared, so that's going to go right here. And that exponents count down, so 3x squared to the second, 3x squared to the first, and then the last one doesn't have the 3x squared. And then the second thing I cubed was the 1, so 1 to the 0, 1 to the first, and 1 to the second. Of course, 1 to the second, or 1 to any power, which is 1. So here's our final answer. We still have that 3x squared minus 1. And the other parentheses, 3x squared squared, well 3 squared is 9, and x squared squared is x to the 4th. This one is just going to be plus 3x squared, and 1 squared, the last term is just 1. So there is our result. In the next video, we will talk about how to factor by grouping, so each of those problems right there.